Hello everyone, so in this video, let's talk about the minimum time to visit disappearing nodes. So as you can see, there's an underactive graph of n nodes. As you can see here, you are given a graph with n nodes, and there's a 2D array edge. We defined that there's an edge between u and v, that is these two nodes, and what is the length? The length of this particular path between two particular nodes. You have to describe an edge between u and node v. So you have to make an edge between them. And it will take a time to travel is length of I units. So you can just assume that this much of time that it is given in length, but you can assume that you are going through some speed, let's say 1 kilometer per hour, and this is kilometer. Okay, so the time it will take, it says 2 kilometers, so it will take 2 hours. Okay, you can assume whatever the 2 is here, it's the time it takes to go from this node to this node. Okay. Initially, you are given an array disappear, where disappear denotes the time it will take for node I to disappear from the graph. So it is also giving you some array. It will take that the first node will disappear after 1 hour. Second node will also disappear after 1 hour. The third node will disappear after 5 hours and so on. Okay. So like this is 0, 1, 2. So this is the overall nodes that we have. Okay. Now you have to find out the answer of I. That is the minimum time required to reach node I from node 0. So from node I to node 0, so from node 0 to every node ith node, how much time it will take. So from node 0 to all the other nodes, how much time it will take to reach that. If the nodes are disappearing at this particular rate, and this is the time it will take to reach a particular node, and will not first of all return -1. Okay, that's the only thing. So that's the only thing. Whenever you have a weighted edge problem, first try to think of it by solving it using dijkstra, because dijkstra has a very simple approach as well, and you have weighted graph, and you have to find out the minimum time. So whenever you have to minimize your route to every edge, and like disappearing or not, we'll talk about that later. But if you have to find out the minimum distance or minimum like anything or cost to reach from like a certain node to all the other nodes in a particular graph that is weighted, then the first thing that you should come to your mind is dijkstra. Now dijkstra can be implemented using two data structures, fatigue and set, but the most good one is set. You can check out first videos of how to implement dijkstra using set. There are multiple videos online. uh, then you can first check out those, then only you can understand this. It's just a pure implementation of dijkstra, nothing much. So if you have a good understanding of what dijkstra is, you can watch any video on how to implement dijkstra using set. It's much more faster than priority queue. Then you can understand this code. This is just a pure implementation of dijkstra, just one condition added more, and the simple thing. So yeah, that's the whole thing. Let's understand how we are trying to solve. I will not go much into dijkstra, but I'm just giving that this is just a pure implementation of dijkstra algorithm with just one condition more added. And so let's see that what we are actually trying to do is that from every node, let's say from node 0 to every other node. So to reach a node 0 from the node itself, so you're starting from node 0 and you have to reach node 0. So it will take 0 time. Okay, so the time it will take to node 0 is 0. Now how much time it will take to node 1? So as you can see that to reach node 1 from node 0, it will take 2. That is 2 hours. Let's assume like it's R, and assuming that let's say 2 units. So okay, 2. Now, but after 1, as you can see, like after 1 unit, the one node will disappear. So if one node will disappear after 1 unit and it will take 2 units to reach it, then it's obviously you are not going to reach it. Like whatever path you'll take, you will not reach 1 because it will disappear before you reach it. So it means that it is -1. You cannot reach node 1. And the last one is that how to reach reach node 2. As you can see that there is one path here and one path here. As you can see that this path takes 4 units and this path takes, as you can see, 2 plus 1, that is 3 units. So this one is shorter, but this node will disappear after 1 hour. So if you like, if it will disappear, like this will too, so you cannot reach this node after this node because this node will disappear. So you will take this route only to reach this 2 node because this node will disappear after 1 hour, and you cannot use this path, even though this is a shorter, much shorter path to reach this node, but this node will disappear. And that is the overall thing. That is one condition that you will be added, that if you reach a node and it disappears, like if it is not reachable, then you will not push that into the set while you are doing the dijkstra algorithm. So how we are trying to do the dijkstra algorithm, you can watch online. But It's pretty much simple from every node. Let's say you try to reach any node, and to reach a particular node, it will take, let's say, W amount of time. Okay. Then to reach all the adjacent nodes, you will just do a for loop and try to see and find out what is the minimum time to reach all the adjacent nodes. To find out the adjacent nodes, you will use a set to find out the minimum time it will take to reach the adjacent nodes. And then you will just try to add them and try to go to the very closest. If you reach a node that is unreachable, because let's say from 0, you will go to 1, and that is unreachable. So you will not push all the paths adjacent to 1 in the set because it is unreachable. So that is why this path will automatically become unexistence for us. This path will only be taken, and if it is possible, then only we'll take this path. So that's the overall idea. You just have to add one more partition. I will like you can watch. You can directly just before solving this problem out, go and check out how to solve and how to implement dijkstra using like using set. If you understand that particular piece of code, then this code is just the same of that. So I will not go into how dijkstra algorithm works or like because that is the not actual use case of this particular problem. The problem is that how the actual problem is solved. Okay, understanding dijkstra is just a complete other video, and that can be used in different problems as well. So what we have done is that we have created a set. We have to find out distance from 0 to all the other nodes. So distance will be stored in the distance. We have to first initialize it with an infinity or very high number. So we initialize with 10 to the 9. Then this is the adjacency list. So we'll create an adjacency list of from the 0th because it's undirected. So from U to V, there's an adjacency map like a edge, and this is the we can say time. Okay, and then from U to V or from V to U also it is active post because it's undirected, and that is the time. So that is how you will store a vector of pair of integers that is an array to store out from U to V and V to U for a particular weighted graph. Now from reaching to 0 to 0, it is 0. Like the time, so this distance array stores out how much time it will take to reach from 0th node to all the other nodes. So from 0th node to reach the 0th node, it is 0 time. So it will initialize it with 0. And because that is for sure we have reached that, so we will insert that particular thing. So this is 0 comma 0. 0 comma 0 means that this is the set. In the set in dijkstra, we have to choose all the edges that is the shortest. We have among all the possible options that we have from a particular node to go to all the other nodes, we will choose the one that is of the shortest time or length, whatever you can say, or weight you can say. So we have to sort them. That is why and set always like sort them in the ascending order by the first value. So or like in these order. So we have to sort them by the edge length. So that is why the first of this is the edge length or the time. Second one is the actual node from which we have like the time it will take to reach that node. So obviously, as you can see that from the 0th node, it will take 0 time. So that's why we insert this in the set. Okay. Now what we have done is that we have to now start our iteration over the set. And what we have done is that we have done a while loop until the set becomes empty. We'll pop out the first element that is the shortest length among all the edges that we have in the set. Erase that from the set. Now take that particular node that we are on. So this is the particular node that we are on. Because the edge that we have reached from the particular node, the shortest edge, what we do is that whatever the shortest edge will take, the node that I will be go to that particular node, what we'll do is that we'll iterate over all the other nodes that is connected to that shortest edge. Okay, we'll do a for loop and then find out the new, you can say the new path. So let's say from this, I can go to here, or from here, I can go from here. So you can see that we are trying to find out from every node what all are the adjacent nodes it is connected to. So as you can see, we are iterating over the adjacency list, as you can see, over a particular node. So let's say I somehow reach this node. Now I will go over all the adjacent nodes of this particular node. Okay, and find out new paths because I have to reach all the other nodes on the 0th node. So we'll iterate over all the adjacent nodes of this particular node and then find out the updated weight. So let's say the weight or the time it will take to reach this node is, let's say, W. So this from reach W to go to this node is W plus the time it will take from this to this, that is, let's say, 2. So plus 2. From here to here, it's W plus 4. Because W is time taken to reach this node. Then I have to go to all the other nodes. So W plus 2 plus 4 and so on. So I will find out the new time it will take. then I have to understand that I will somehow only go to this node if it is not disappeared. So that the new time that it will time to take to reach this node, if it is less than the disappearing time to reach that particular node, and this distance to reach that particular node is smaller. We have not find out like if so let's say to reach this node, there can be this path and this path. If this path is much smaller, if this path is much smaller, then only we should push that inside the set. If we have already find out a much smaller path, why we should take a larger path and push that into the set. So if it is smaller, if the new path that we have find out, the new distance, if it is smaller than the actual distance that it is already stored, it all initializes to a very large infinity value. If it is the first value or much smaller, it will always get replicated. If it is a larger one, it will not get replicated. So these are two conditions. In the actual dijkstra, this condition is not there. Only this condition is there. So we just have just the complete dijkstra algorithm. Just one condition is added, that is this. If this condition is removed, then like if condition is added, then it's like the problem. If this condition is removed, it's just a simple dijkstra algorithm implementation. So simple dijkstra algorithm. If we just find out a smaller distance, what we'll do in set, we'll remove from the set if there is a path that is already there that we are traversing. We have inserted a particular from a particular node. Like if we have already seen a particular smaller path, we have to remove that particular path, update and find out that we have seen a much smaller path and push that inside the set. If you have already seen a dijkstra algorithm video, it all becomes sense. It's just a very standard dijkstra algorithm code. I have not added a single line. If I just remove this, it's just a standard dijkstra algorithm code, nothing much. So yeah, and that's it. That's it in the end. Now in the end, we have find out the minimum distance to reach all the particular nodes. But as you can see, if the node is unreachable, then you have to make it at -1. But we have initialized it at like a very large value, 10 to the 9. We have gone through this. We have initialized with very large value, 10 to the 9. We have seen this. Yeah, this here. So we have to not make it 10 to the 9, but at -1. So we iterate over this distance array again. And if it is the value 10 to the 9, then which means that we have to make it as -1, not 10 to the 9, because we have to show in the end -1, not 10 to the 9. So that's the overall, like you can say, more updation that we have to do before printing out the answer. And then we just return the actual distances that we have pointed out. So that's the complete logic on the code part for this particular problem. If you still have any doubts, you can mention in the comment box or the video. I will see you in the next one. Keep coding and bye.